Hi, my name is Louise DeBoisa and I'm going into 9th grade. Unit 1 explains exponents, radicals, and rational expressions. In the unit, you learn about the exponent rules, simplifying perfect cubes and squares, converting between radical and rational expression forms, multiplying, dividing, subtracting, and adding radical and rational expressions, and using exponent and radical rules to simplify expressions.
Hi, this is the problem. We're going to start by solving the problem with this part right here. x3, x to the power of 3 to the power of 2. We're going to take it down here and we're going to solve it with something called the power of power rule. The power of power rule is when you have a variable like this and you want to solve it. So in this case, x to the power of 3 to the power of 2 is the same thing as x to the power of 3 times the power of 2. So x to the power of 3 times the power of 2 is x to the power of 6. Now, we're going to take this and we're going to plug it in on the top and solve the whole top problem with something that's called the product of powers rule. The product of powers rule is when you have two variables that you want to multiply, but you have exponents. And in this case, we're going to leave the y apart and take it out of the problem for a quick second because we cannot combine the like terms with the y because it has no like terms. But with the x's, there are two x's, so we combine the like terms. So we're going to take x to the power of 6 and x to the power of 4, and we're going to add the exponents. X to the power of 6 plus to the power of 4 is x to the power of 10. So we're going to take this, and we're going to plug it in the top equation. Now we're going to take the y back, the y to the power of 2, and we're going to put it back in on the top. So now the full equation is x to the power of 10, y to the power of 2, over x to the power of negative 2, y to the power of 0. We're done with the top part, but now we have to work on the bottom part. The bottom part, you can notice that there's a y to the power of 0. So we're going to take this, and we're going to use the zero exponent rule. The zero exponent rule means that when there's a variable or number that has the 0th power, you're going to turn it into a 1. There are no exceptions, nothing. It will always be a 1. So the bottom part now, with the simplified version of the x to the y, the simplified version of the y to the power of 0, is x to the power of negative 2 times 1, which is just x to the power of negative 2. Now we're going to plug this back on the bottom, and we're going to use the quotient of powers rule. The quotient of powers rule is when you want to divide two variables or numbers that have exponents, which is in the exponent rules, like all the other problems. We're going to take the x to the power of 10 and x to the power of negative 2, which are like terms, and we're going to divide them. Like the last time, we're going to pull the y aside because it has no like terms that we can divide it with. Because we cannot divide x to x and y. Now we're going to take the x to the power of 10 and x to the negative second, and you're going to divide it like it is right here. Now we're going to take the x to the power of 10 and we're going to divide it, which just means you subtract both exponents. But in this case, there's a negative exponent, so it becomes a plus, because two negatives equal a positive. So it becomes x to the power of 12, because 10 plus 2 equals 12. And then the final equation, we're going to pull the y back in, and our final answer becomes x to the power of 12, y to the power of 2. Now we're going to go on to the second problem. In this problem, this goes on the second category. In this equation, it asks me to simplify 3 square root 80. We are going to simplify by factoring. We are going to try to find the lowest number you can divide 80 by, which is 2. 80 divided by 2 is 40. Now we're going to do the same thing with 40. 40 can be divided by 2, which is 20. And you just continue that same process until you have two numbers where the number that's on the right side cannot be divided, which in this case is 2 and 5. So we're going to make groups. We're going to make groups with the same numbers. So we're going to use both 2's in this case and both 2's on this case, and then we're going to leave the 5 aside. And now I wrote down a little rule that if the final numbers are left and are not identical, then you multiply them out inside the square root box. In this case, we don't have two final numbers that are alone and that aren't identical. So we're going to group them, and we're going to fill in the square root box. We're going to take, in the original square root, we can find a 3 here. The 3, you're going to add it outside the square root box right here, and you're going to take a 2 from here and a 2 from here, and you're going to multiply all of them, which makes 2 from one of these 2's times 2 from one of these 2's times 3 from the top And then you find the square root, and you're going to use the final number, which is 5, and you're going to plug it in the square root box. Now if you multiply 2 times 2 times 3, it makes 12, because 2 times 2 is 4, and 4 times 3 is 12. And you're going to leave the 5 inside. That is your final answer. Now that we solved both categories, I hope you can understand better both concepts.